In the previous video, we used a continuous time system to describe how to compute the zero input response. In this video, we're going to focus on the impulse response using a discrete time system. If we recall, we can have a system. In our case now, we have an output and an input, xn and yn. The impulse response when the input is equal to delta, the output is the impulse response denominated as h of n. So the equation is given here, the relationship between the input and the output. Now we need to know the response of the system when the input is a delta function or an impulse function. We can see that from this equation, we can write it as E plus 2 y of n equal to xn, which is the input. Now our input is equal to the delta function, which generates an output yn equal to hn. We know from the response of the system is that the delta function is very short in time. That means the response of the system, as demonstrated in the book, will be a combination of the influence of the impulse plus the characteristic equation. When x is equal to n, that means when the impulse disappears. Therefore, it is shown that the impulse response is the sum of B0 divided by E0 delta n plus some characteristic equation. If we recall that the E in this case is actually given in the general form, Pn minus 1, that means the derivative of order n, is B1 E plus B0, and then this is for the input. Therefore, the coefficient A, B0, and A0 are the ones that are given as a ratio between, as the weight of the impulse response. If we look at now in E plus 2, now we put yn equal to xn, we see that B0 is equal to 1, which is the coefficient of xn, and then E0 is equal to 2, which is the coefficient of yn. The response of the system when the input equal to 0 can be obtained with the exponential function as the output, as given in this way for discrete time system. In that way, from this one, we can compute gamma plus 2 equal to 0, and then gamma is equal to minus 2, which is our characteristic mode, and therefore our impulse response Hn will be the ratio of B0 and 2 delta n plus some constant minus 2n. Now we need to determine the value of C. To find C, we need to find one element of Hn, knowing that using the iterative solution as also shown in the book. In this case, what we've got to find is to find either H0, H1, and so on. If we look at the original equation and replacing Y by H, we have Hn plus 1 plus 2 Hn equal to delta n. And we're knowing that the initial conditions as causal will be equal to 0. We can then try to set H minus 1. That means we try n equal to minus 1, which will give us H minus 1 plus 1 plus 2 H minus 1 equal delta minus 1. So we have H0 plus 0 plus equal to 0. That means H0, initial condition, is equal to 0. And then we can replace it in our equation Hn equal to 1 over 2 delta n plus C minus 2n by replacing by H0. That gives us 1 over 2 delta of 0 plus C minus 2, 0. We know this is 0 equal to 1 over 2 plus C, and this gives C equal to minus 1, 2, and therefore our impulse response is equal to 1 over 2 delta n minus 1 over 2 minus 2n, and then this is causal. This is how you compute the impulse response, and we have used the discrete time system. Thank you very much for watching.